Welcome to the Capital Light Assembly podcast brought to you by Edison Manufacturing and Engineering. Edison is your contract manufacturing partner focused on capital light assembly of complex mobility and energy products that are not well suited for highly automated production. Brandon Bartnick here, joined again today by Frank Webb, our Director of Engineering. Frank, thanks for coming on the podcast again.
Likewise, thanks for having me.
Yeah, this will be fun. So we've third appearance here, I think you're making. So we've talked previously about quality. We've talked about delivery. Critical, especially for the types of products that we're talking about here. Relatively low volume, typically high change, whether it's the product or the market high degree of uncertainty often. And it's mandatory that whoever is manufacturing is able to do it in a reliable, repeatable way that provides a high quality product and also is able to meet delivery timelines. Now we're talking about, I think, the third leg of the three-leg stool that people are familiar with, which is cost, delivery, and timing. So talking cost right now. And yeah, we're going to unpack that a bit and talk about what that means in this world. So I think maybe let's first talk about upfront cost. So when we're talking capital light production, one of the pillars here is not requiring an abnormal or a crazy amount of upfront capital to get started. Can you talk about what goes into developing a production system that is capital efficient upfront?
Yeah. On the whole spectrum, right? You can go from a traditional OEM or a tier one type of an environment where they'll make 1 million water pumps for you a year, right? And there's going to be a lot of tooling up front. There's going to be a lot of expense and automation. But generally speaking, you're going to get the exact same water pump every single time, and you're going to do it at a really low piece price. That's why you can swap out the water pump on your 10-year-old car for a $150 part. On the other side is the phraseology we used to use is the welding barn, which is you can get a bunch of guys that are mechanically, or gals that are mechanically inclined, that are craftsmen sometimes, and they will put together a low volume, usually single digits of units, and you won't have to spend nearly anything up front unless there's something absolutely required, like you're casting a piece that has to be cast. But you can look at those two different approaches. The trick is a lot of places fail to make a good bridge in the middle ground, where you need that high quality and you need at least reasonable piece price, and you need that repeatability, but you don't have the money to spend on that 5, 10, $15 million assembly line. So the real magic, at least where we've spent most of our time at Edison, has been in that middle ground and deciding how much to turn up or down that upfront investment. There's still a scale, even in the volumes and the types of programs that we tend to work on, that I've worked on in my career, that for the same product at the same volume, we can have those discussions of, do we spend $10,000 on a fixture or do we spend $1,000 on a fixture? What's the real trade-off there? How many minutes are we going to save an assembler's time? How many parts per million or parts per thousand sometimes of failure are you going to have? And what is the cost of putting a detection into that system so that doesn't escape? Mm-hmm. And so that scale is oftentimes something that we're talking about when we're writing proposals. Oftentimes my ME lead and I will sit down and we'll look at his fixture costs and say, I think we ought to increase that in order to take some time out or take some uncertainty out. And really the goal is to align the scope of the program and the scope of that investment with what the actual end customer needs. And not just like the end consumer, right? But the customer being the company that's trying to bring this product to market. What do they have as resources and what do they have as requirements? And then what type of demand do they see and what type of margin are they going to get on the end product? Because all those things come together in kind of a multivariate sort of a problem that's difficult to quantify. But when you start to dive into the individual pieces, for example, we recently spoke about battery pack assemblies for a particular potential partner that we're talking to here. And we're trying to decide how we wrap a particular type of isolator around a battery cell, like a 21700 cell. And we could spend $50 on a little nest that we print in our own 3D printer and help you roll it around, and you rely on the operator to put an adhesive tape on there. And then you have an inspection process and a couple of different things in order to make sure that happened correctly. Or do you spend a few thousand or even $10,000 on a fixture where the operator is going to pull a lever or press a button and all of this is going to happen automatically? None of those things are what you would see on an actual industrial assembly line for battery pack manufacturing. There would be no fingers touching the cells in a real volume environment. But even within our smaller niche, there's scales to automation, and it doesn't necessarily look like what you would consider automation in this sense, but there's scales to how much we invest in the tools and in the training of the operator, and sometimes the caliber of the operator itself. Are we going to be looking at a ASE certified mechanic or somebody with equivalent set of skills, or are we looking for something that can be a lot more accessible to a different level of operator, a different level of experience and mechanical aptitude?
Mhm.
And all of those things are kind of knobs that we can push and pull. And that's why we often have all these upfront conversations about, where do you see this going? How confident are you? Right. Not that we're trying to necessarily vet the customer and decide if they're going to be successful, but trying to tailor the approach to the assembly line design and the tooling and fixturing that we're actually going to choose or design, in order to really achieve what that customer, that partner we're working with, actually needs.
Mhm.
And sometimes it is a little bit of a, well, let's take a step back, right, and offer some trade-offs. Right, there's a risk in their volumes, and this is the cost of that risk. And then make a plan on implementing that potentially later at a different time when volumes become more confident.
Yeah, one of the things I've come to appreciate watching the way that you make these decisions and working with our team to define a manufacturing and production approach is it's not, we're not just taking things at face value. We're asking questions. We're understanding why and how questions, and it's like, I don't know. Even just recently here, we were talking right about getting asked to build one of something, which we can
Mm-hmm.
do. There's a lot of ways that we could build one of something. The question is, what comes after that? What is likely to come
Right.
after that? And the tough thing is, a lot of the situations and the products that we're talking about, which are making this jump from proof of concept into low volume production, often like no one actually knows exactly what that volume curve is looking like. So we're trying to figure out with our partners and customers, like what's likely to happen, what's the probability distribution, what's the cost if we overinvest and make it, too complex up front versus if we make it not as complex as we could have. Like, how do we scale these things? And I appreciate how, you're weighing all of these things to put together a solution that we think gives us the best solution for the customer and the product, while also maintaining optionality and mitigating risk and all these things.
Yeah, and that particular customer that you're talking about, we had to get down the rabbit hole of, we want to build one right now. That's understood. Are we building one in preparation to then build 1,500 of them, or are we building one just to take that away, learn from it, and then build a second one in preparation for building 1,500, or third or fourth? Right? Where do we think that point is? And with that particular customer, interestingly, we were able to get to a very honest point with them, right? Chatting about, we need to learn how this first one goes together and what the customer wants out of it. All right.
Mm-hmm.
Right. Now we're not going to look like the welding barn example necessarily, right? We're going to have the engineers out on the floor with basically reams of documentation and prints, and we're going to have CAD spun next to the vehicle while we're building it up in order to capture these things as we're learning them. But we're not going to set up an assembly line. We're going to set up a very flexible assembly cell, right? We're going to be bringing the tools and equipment to the product rather than vice versa. And we're going to use a team of engineers and mechanics that are prepped for this, that understand the context of what we're putting together here. It's a joint development effort at that point, and that's a different approach than if somebody has already built 5 or 10 of these in their own shop and they're pretty confident of what the product needs to be. They just need to get it over the hump to make it reproducible in a efficient fashion. We're probably going to jump a little bit further ahead on setting up that assembly facility in a little bit more sophisticated fashion. We're going to start investing a little bit more time in MES and work instruction templates in order to say, we've jumped past that very early stage, and now we're into the manufacturing, the DFM, DFA, and then the manufacturing process development.
Mm-hmm.
And so the where exactly on the life cycle, right? That's what we like to talk about with our program management folks here at Edison, is where are we on the life cycle, right? Most products go through a relatively similar set of steps or phases in their maturity as they grow up into a mass produced, or some kind of repetitively produced product. And so where are we on that cycle? How mature are we? And some of that is working with the customer to learn what they already know. Some of it is sharing what we have seen in the past and what we know from experience with the customer, and coming to that single picture of, in that case, it was, we need to build the first one that wasn't built in a garage. All
Yep.
right, let's do that, and let's prep for it, and let's make sure that we're getting the learning we need to out of that. So when we go build 500 or 1,000 or 1,500 of them a year later on, it's a much smoother transition, but we're not over investing up front, right? We're not setting up a bunch of engineers to try and write process instruction for something that's probably going to get thrown out after the first one comes off the out of the assembly facility.
Yeah, and it might be surprising that this conversation almost entirely so far has been at a strategic level, right? We haven't talked much. You've touched on a few kind of tactical type things, but I mean that's kind of, we take that for granted, but it is a critical piece that we need to have all of the tools in the tool belt and enough experience and um, ways of executing certain things so we can throw the right tactic at the problem. But I think what we're talking about here, really, this strategic decision of understanding what is it that the product and the customer and scenario actually needs, and then crafting a dedicated solution optimized for that. Like, I think that's where a lot of the magic is. And then you're taking the tools and you're putting them together, but like, it's really having this honest collaborative partnership discussion about what's the right strategic way to execute this, right? Like, that's the foundation.
Yeah. Those technical tactical solutions are sometimes really interesting. For example, when I was involved in putting together Google's first self-driving cars, the tactical solution on how we got the right adhesive wet out inside of those frames, and how those things were bonded, and how the stress calculations were done, and how we were confident they were going to survive in the different crash scenarios that they were going to survive in. That was all really cool technical stuff. But you can't solve the right technical problems unless you know where to focus your attention. The technical problems tend to they don't solve themselves. Obviously, you need a lot of
Mm-hmm.
smart folks with a lot of experience and a lot of really creative juices in order to solve those problems the right way. But that effort is wasted if you're not putting it at the right place, right? If we're not focusing it on the right part of the product or the process in order to remove a pain point. If we don't know, we can't do that effectively if we don't know what pain points matter the most right now. You can't know what matters the most right now unless you know what right now is and what the next step is. And it's a thing that is common in PMI as well. The Program Management Institute is one of the best senses of a program manager is, where am I in the program? What phase of the program am I in? And what's next? And if you can apply that same type of methodology to the product development life cycle, everyone's a little bit different, but they tend to follow a very similar over, like, story arch, for example. They tend to follow that similar story arch, uh, knowing where on that arch we are roughly and what is probably coming next can really inform how we approach those different technical solutions, and know where we actually have to put the brain juices to solve a pain point, or to maybe to not solve a pain point yet and plan to do it later.
Mm-hmm. Yeah, it's really interesting. And I mean, from a back to the beginning of this conversation of this balancing between cost, quality, and delivery, right? Like, there's always trade-offs. It's
Mm-hmm.
making the decision of what, and often these trade-offs all can come back to cost, or they somehow come back to what is the right solution for a customer, what's going to maybe cost them the most long term. But it's not like, it's not always a what's the right cost for a piece price. Like, you're zooming in and out, and you're talking about what's the cost of poor quality, what's the cost if we miss a delivery, what type
Mm-hmm.
of expediting costs are we going to incur if we're late getting something final. Like, these are all different. It's a much more nuanced, multivariable calculation. It's not just as simple as kind of black and white.
Yeah, it really isn't black and white, and that's what you find a lot of times in manufacturing. Is an organization finds their core expertise, right? They find what they're really good at, or they find what, at the time that they're learning how to be an organization together, they find what the market needs, or they find a market need that fits, right? Regardless, there's a lot of momentum that tends to build up, because manufacturing organizations tend to be investment heavy, not just in physical investments, but in personnel expertise, experience, process development. That's a big one that you get a lot when you walk into a larger established contract manufacturer or tier one. Is they've got processes that have been in place sometimes for decades, or double digit decades, right? When you start getting into the big ones, and those processes are there, just like safety regulations, right? They're born in blood, sweat, and tears, and there's a good reason that those exist, and they've become a fabric of the organization. But when you have that, it's very difficult to rewind, right, all those hundreds or thousands of procedures or learnings or templates and things, and decide which ones of those actually apply here. And that's what we try to do differently. Is we've got our own, obviously, internal processes. We're ISO compliant and just got our certification, so we have all of that going on. But we try to be very specific on where we put those processes and what level of abstraction those processes are built on. And for what we mostly do, the processes exist to set the context and help us develop the commander's intent, so to speak, of what the actual activities in the program are going to be. And a lot of that is setting out the team's headspace correctly when we're engaging with a new potential partner or customer, to say where are we, what are we going to do next, right? Like we were just saying, and how do we stay creative in that environment, and then start to be really intentional while we're being creative on what are we trading off with each one of these decisions, and how exactly are we going to manage that decision making process.
Yeah, and I think this is a great place to leave it, so we won't dig any deeper. But one kind of further wrinkle that makes this even more fun is that like very few of these data points that we're talking about are going to show up on a requirements document, right?
Right.
Like the type of things
Almost none
that
of
we're
them.
using, like there's a lot more that goes into really understanding the situation and understanding and being collaborative and being a partner and being trusted and trusting of the other side to come up with a solution. So like, yeah, you add all the human elements and things that come with it. So yeah, Frank, really appreciate it. I think this is a great overview of kind of the strategic aspect of how are you designing an intentional production system, assembly process, manufacturing process for a given product with overall cost in mind. So yeah, thanks.
Absolutely. Thanks for having me.